let's just jump right in there and do another problem. The more you do these, you're like, oh, I get it. So like I said, I like to take the balanced equation and go ahead and write the information underneath the balanced equation, what I know. So it says, what is the concentration of H2SO4? So I'll find my H2SO4, and I'll put question mark, and I'm going to go ahead and put question mark big M for molarity. Remember, what I'm after then is, what is molarity? That's moles, in this case, of H2SO4 per 1 liter of solution. So that's my target. What else does it tell us? Well, it says, what is the concentration of H2SO4 if 25.0 milliliters of the solution. And the here means that, of that solution. So the volume of my H2SO4 is 25.0 milliliters. What else I got? If 25.0 milliliters of solution required, 27.7 milliliters of 0.444 molar NaOH. So now I know two things about the NaOH. I know the volume, 27.7 milliliters, and I also know the molarity, 0.444 molar. So now this is a little bit different, isn't it? Can you see where our first step, actually we're going to take advantage of knowing more about our NaOH. Specifically, you're always going to go from what you know to moles. So do you see where we can get to moles of NaOH using the molarity, or I'll just put volume and molarity. How's that? We can do that. Well, now the pattern is to go ahead and go then to the other thing. Now in this case, we're going to go, our second step is going to go from, once we have moles of NaOH, to go to moles of H2SO4. How can we do that? Using Stoich ratio, just like we did in our grams to grams problem. Okay, so now if I have moles of H2SO4, do you see where once we have moles, we can get to molarity of H2SO4 if we, H2SO4, if we simply take the moles that we got and we divide it by the volume that was given. I'll kind of show you what that looks like. Okay, so here we go. Sometimes chemistry problems, you just kind of waddle on down the road and see what you need to do to make this work. And with this aqueous solution stoichiometric calculations, you just kind of start in with what you know most of. So I'm going to title this moles of NaOH in that volume molarity. Again, if I was titling this, probably I would just say moles of NaOH, and then I would go ahead and use that volume molarity. It's kind of like we did with the previous problem. If I go ahead and start with my first term as 27.7 milliliters of solution, that's great. I need to go ahead and convert that to liters. How can I do that? We can do that if we introduce 1 liter over 1,000 milliliters. Excellent. I'm going to go ahead and ask you now, how can I use this information right here to go ahead and have liters cancel and be left with units of moles of NaOH? And the answer is, dun dun dun, what I call the unflipped version of molarity. So if we simply put, we're unpacking that 0.444 m. I should never see an m when you're going to do this sort of calculation. What that means is 0.444 moles of NaOH per 1 liter of solution. Now our milliliters have canceled, our liters have canceled, we're left with moles of NaOH, which is great. Oh, don't forget to divide it out. How do we need to round it? I'm liking 3 sig figs. So 3 sig figs is shown here, so 0.0123 moles of NaOH. Excellent. So now we're on our way to the second step, to go from moles of NaOH to moles of H2SO4. The first term is going to be those moles of NaOH that we got. Now tell me how I can go ahead and use this information from the balanced equation to have a stoichiometric ratio so I can get from moles of NaOH to moles of H2SO4. What does that look like? Yep, it looks like this, where here's our stoichiometric ratio. we took the 1 in front of the H2SO4 and we took the 2 in front of the NaOH, and life is grand. Okay? Unit-wise, we're left with moles of H2SO4, round it to what? 3 significant figures. I get 0.00615 moles of H2SO4. So that's what I call the situation year. Those are our moles of H2SO4 we must have in that volume of H2SO4. I told you the last step is to take those moles and we're going to divide it by the volume that was given. This last step, like I said, is the kind of wild child in these sort of calculations. So to get molarity, now we know moles and we know that volume was given originally. So what I usually do is simply take the moles over the volume that's given. Now you might see that there's an issue here, I don't know, an issue, but molarity is always in units of moles of solute per liter of solution. Okay, so how can we get our denominator from milliliters of solution to liters of solution? Well, if we introduce the relationship between milliliters and liters and put milliliters on top and liters on the bottom, that'll do it for us. So notice now the units we're left with is milliliters have canceled. We're left with moles per liter, which is great. I'm liking, how many sig figs do we need to round this to? We're going to round it to 3 sig figs because there's 3 here in our moles of H2SO4. And remember, don't forget that trailing 0 after a decimal is significant, so we round it to 3. I mean, that's a good example of if you weren't careful and if you just simply, and I know we all get in a hurry, but if you just simply write 25 under your H2SO4, you're not going to realize when you go to work this problem that actually there's 3 significant figures in that volume. So very good. That's the second of a few calculations.